welcome back to the Smart Learning channel, where science and mathematics are going to be fun, and also you will learn that both subject as easy as ABC, right? Okay, in the previous session we discussed about the composition. It means both combining both reactant and giving a single product, combination reaction, decomposition reaction, and their types. We discussed it. Today in this session, let's discuss about the next types of reaction, that is exothermic reaction, endothermic reaction. Again we have displacement reaction, double displacement reaction, oxidation reaction, reduction reaction, and redox reaction. These are the types of chemical reaction. Now in this session, let us discuss one by one. So let me go with the first, it means third reaction. It is third reaction, that is exothermic. Exothermic reaction. What do you mean by exo? Exo means outside. Exo means outside. Endo means inside. We have next type, that is endothermic reaction. Therm means heat. Therm means heat. It means outside there is the heat liberated out from the reaction is called exothermic reaction. Okay, ma? The reaction in which heat is released is called exothermic reaction. Exothermic reaction. Okay, heat is liberating out. When the reactant are reacting together, then it feels as heat. Heat is produced. See, for example, the best example is, as we seen, combination reaction, calcium oxide, CaO plus water. When we put calcium oxide, which is called sunna, right? Calcium oxide in water, the beaker, when you put water in calcium or calcium oxide in water, when you touch the beaker bottom, it feels heat to you. It feels heat definitely. So then the product formed in the beaker is calcium. Very good. Calcium hydroxide plus heat is liberated out. See, heat is coming out as a product. Calcium hydroxide is the main product, which is exothermic reaction, the best example. And we have burning of natural gas as a second example. You can see that burning of natural gas. Which is a natural gas? Methane. CH4. This CH4, about methane and everything, you are going to discuss in carbon and its compounds, the fourth chapter of chemistry. Very beautiful, very large chapter, very biggest chapter, and most fundamental chapter too. And this is methane, how to write the structure and everything you are going to discuss in that chapter. Don't worry about that. When methane is reacted with oxygen, it means in the surrounding of atmosphere, then the formed products are carbon dioxide, one of the most common product is formed, but then water plus heat in the form of energy. In the form of energy, heat is liberated. Actually this heat is called energy itself, okay, but it is the energy, the main byproduct, but energy is converted into heat, which is an exothermic reaction. Okay, right. These two are the famous example you can mention in your answer for exothermic reaction. And also We have respiration too, C6H12O6 glucose. When we react with those with oxygen, we get carbon dioxide, again water, and we get the energy. Same product we are going to get when we react to the glucose, which is called respiration. What we take, what we give, everything. Some heat is liberated out. See, you know that our body will give the radiations in the form of heat. Some people's the body is heat, not as much normal or not as much as cold. They are producing heat. When we measure that the body heat when it's coming out, then you will come to know so that the human body also exothermic. Clear? This is all about exothermic reaction. Exothermic is completed, means the heat is liberated or released out, what we call, that is exothermic. Coming to the next type, that is fourth type of chemical reaction, that is we call endothermic. Endothermic. As I told you, endo means outside, no, inside. Exo means outside. Thermic means heat or a temperature, whatever you call it as, which is known as the reaction which required the heat. By heat only the reaction will proceed to give an products. Okay, let me write a definition. The reaction in which heat is required, heat is supplied or heat is required. Okay, heat is supplied in the form of energy or a sunlight, whatever it may, is called endothermic reaction. Clear? The reaction which heat is supplied is called endothermic. Now coming to the examples, most common quite example when we see in decomposition reaction, right? Before going to example, I will give another statement to you so that you are being familiar with the concept. That is, all decomposition reactions are endothermic in nature. Endothermic reactions. Clear? Right. For example, 2FeSO4, when we heat it, we get Fe2O3, ferric oxide, plus sulfur dioxide plus sulfur trioxide gases are liberated out in the form of heat only. It is a product, main product, ferric oxide, where these two are harmful gases which we seen in the decomposition reaction only. Okay, harmful gases, sulfur dioxide and sulfur trioxide. Clear? Right. And another example, a famous example, I am going to rub this definition because it required space. Photosynthesis reaction, right? Did you remember that? Photosynthesis, very famous endothermic reaction which required sunlight, carbon dioxide plus water. When carbon dioxide plus water is reacted by themselves, then in the presence of sunlight, when we see it, or we can also tell in the presence of chloroform also, chlorophyll or chloroform, it gives C6H12O6, which is a glucose as a product, plus the byproduct which gives as oxygen. Clear? Is it clear? Carbon dioxide, water. What is the carbon dioxide here? Which we liberate, we humans liberate, right? That when we react with water, this photosynthesis is seen in plants here. Yes or not? Photosynthesis is seen in plants. Photo means sunlight. As I told you, photochemical decomposition reaction. Yes, this is the reaction, and it is also example for endothermic reaction. Endo means which required heat. Exo means which heat is liberated or which heat is released to the environment. Is called exo and endothermic reactions. You should see the difference between these two reactions, endo and exo. Okay, this is the third and fourth reaction. The next type of reaction or type of chemical reaction is displacement. See, we have completed 4 now: combination, decomposition, exothermic, endothermic. Now let us go for fifth type of reaction, that is a displacement reaction. Displacement reaction. What do you mean by displace? Something, a placing or mismatching or changing one from another, which is called displacement or displace. Displacing something by something. See, now I am going to displace this black marker with blue marker. It means in the place of black marker I am going to use blue marker here. It means black marker is displaced by blue or blue displaces the black. Likewise, the reactant replaces the product. I will going to write the definition now. The reaction in which more reactive metal, the reaction in which more reactive metal, more reactive element or metal, non-metal, whatever, all over the periodic table, more reactive metal displaces the least reactive metal or an element or a non-metal, whatever element. It means what? The larger who have powerful, that will replace the weak one. See, black is everywhere black, but blue, when I write, your eyes is going blue, you are not going on these many black. So it proves that blue is the dominant one in the by comparing black and blue. High authority peoples replaces the low authority people. High power people replaces the low power people. Likewise, which element is high reactive, that can displace, that can replace the least element. For that, for example, I am going to write now example for you. Which is the best example you think? Fe. See, Fe means iron, right? Copper sulfate. When Fe is reacted with copper sulfate, it forms FeSO4, ferrous sulfate, plus Cu as the product remains in the solution or it remains in the reaction. What do you mean by Fe? Nails, iron nails, when you stamp for the wall, that iron nail is iron, no, it is iron nail, iron, Fe. You dip in the solution of copper sulfate, which means that which is in blue color. Copper sulfate is in blue color, this kind of blue. When I dip that iron nail in the copper sulfate, you know that iron nail completely changes into brown color, because in the place of copper, in the place of copper, iron is replaced and forms ferrous sulfate, which is FeSO4. It means what? Now Fe is more reactive. This Fe is more reactive then. Sir, how did you know Fe is more reactive, copper is least reactive? Obviously, I wrote by the reactivity series, we are going to be decide the products. So, what is reactivity series then? What is reactivity series? Elements are arranged in the decreasing order of their reactivity or reactive. See, these are the elements listed in reactivity series: potassium, sodium, calcium, magnesium, aluminum, zinc, right? Iron, tin, lead, hydrogen, copper, silver, gold. These are all. These are the reactivity series. What the definition saying? That decreasing order of the reactivity. It means what? Gold is least reactive, potassium is high reactive. Potassium can replace the gold easily, or whatever else these are all. Potassium can replace sodium, calcium, all to gold. It is the most reactive metal or most reactive element. So, I bring up with the trick to you people. See, this is a definition here, very important concept reactivity series is, and this is a trick to you people. What is that? What and all? How to remember? How to write the product of this reaction and everything. Okay, let's see here. Please stop calling me a zebra, instead try learning how copper saves the gold. This is a statement done by me. I am going to tell you people that please stop calling me a zebra, instead try learning how copper saves the gold. I am going to tell a statement to you, this statement. Then you should find that in this reactivity series. In this statement you should find reactivity series. It means what? See, first letter always says the element name. P stands for potassium enema, right? P stands for potassium, please stop. S stands for sodium, Na, K, calling, Ca, calcium, symbol Ca. Don't be confused with copper here. Me, what do you mean by me? Magnesium, M, first letter. A, aluminium. Zebra, zinc. Instead, iron. Try, tin. What is the symbol of tin? You should be remember here, SN. SN, okay, no problem. Learning, lead, Pb. H, obviously you know the first element of the periodic table. Hydrogen. Copper, as it is. Symbol, very good, Cu. Saves, yes, first letter S. It means what? Silver, Ag, not Au, Ag, don't be confused. Gold, as it is, Au. You should see whenever the reaction gives to you people, if it is a displacement reaction, you should see the reactant and the first element of the first reactant or second reactant, and then you should see the reactivity series and should write the product. See, now let us write the react products for this by seeing reactants. Okay, copper, as I told you that first example, Fe plus CuSO4, FeSO4, right? Fe is here, copper is somewhere else, it means it can replace as this product is formed. Now see, copper is here, zinc is here, then it means what? Least reactive element can replace as the high reactive metal? No. It means what is the answer to this? No reaction you should write, no reaction, it is not possible. Okay, and this is homework to you people, you can write very easy, right? This is the reactivity series, elements which are arranged in the decreasing order of the reactivity, and it is a trick. Please stop calling me a zebra, instead try learning how copper saves the gold. The first letter of the statement gives the potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, silver and gold. Okay. By this in this session we discussed 3 reactions: endothermic, exothermic and displacement. Okay. Exo means heat releasing, endo means heat required, displacement means high reactive metal displaces the low reactive metal. Like that the reaction goes on. So every reaction should be balanced here, and this should be commented in comment box, everyone. Okay, we are waiting for your results. Let's see how many people will write the correct one. So by this I am going to stop this video. Let's start with the next type of reactions in the next video. Until then, keep learning. Thank you.